Make sure you define those inscribed angles there. Intercepted arc, inscribed in, circumscribed about. So, what's an inscribed angle? Go ahead, Hannah.
Well, I don't know how to summarize it, but I don't know how to draw it.
Tell me how to draw it.
Okay, so you have a circle.
I have a circle.
Yeah. And then you have a center, which is like O in the picture. And then you have an angle from, it could be anywhere. And then you have two chords intersecting on one point.
Wow, I like that. Two chords intersecting at one point. Good. That's an inscribed angle. Your angle, the endpoints of your angle touch all three parts of the outer edge of the circle. Okay, and we're calling that circle O. Well done. My circle's not that beautiful, but that's okay. Okay, we'll zoom in there. That makes it even less beautiful. That's okay. Inscribed in. So this angle is inscribed inside the circle. The circle is circumscribed about the angle. Okay, so just some terminology there. Okay, the circle's circumscribed about the angle is inscribed in. Just so if you see that terminology, you know what it means. Intercepted arc. What is an intercepted arc? Especially using our picture there. Jordan, what do you think?
Well, it would be, how to describe it that, like...
Let me label some points here.
Yeah. It would be arc BC.
Arc BC, good. Arc BC is the intercepted arc. It's where our angle cuts out an arc. All right? Questions 3 through 6. So let's, oh, you know what? Check this picture out. That looks like the one right out of the book. It's not quite as nice as mine, but yeah, we'll use it. Okay? Good. So here's our intercepted arc. All right? And then we have our other definitions for those of you that drew the picture. All right. Let's go through question 3 there. Question 3, in the diagram at the left, which arc does angle A intercept? Volunteer? Bree? Arc what? DAB? Yeah, so D. So we've got angle A. It does start at arc A, or arc D, or point D, excuse me. Did you say DAB or DCB? DAB. It actually goes this way. So think of a snow cone, right? So it's like the top of the snow cone. Okay? So DCB. It goes from endpoint to endpoint.
Would you have to do 3 there?
You don't have to put the C. You just say DB. Okay? Remember, DAB means that would be like a major arc, right? If there's if there are 2, then it's a minor arc. If there are 3 points, then it's a major arc. Which angle intercepts angle DAB? Eli, what do you think? Angle, or arc DAB, excuse me. Huh? Oh, okay. Nick, what do you think? It's okay. It comes back around. It's like in a circular loop. Okay. We'll come back to it. Andrew?
Angle C.
Angle C. Yeah, good. Angle C. So we want to start training our mind to seeing those angles and then the intercepted arc. Okay? This will be angle C. Okay, number 5. Is quadrilateral ABCD inscribed in the circle, or is the circle inscribed in quadrilateral ABCD? Jody, what do you think?
I think that the ABCD is inscribed in the circle.
Good. ABCD is inscribed in the circle. Good. All right. Okay, any questions up to there? All right, so we're just kind of training our minds to see those things. Nick, what do you think?
How would you know the difference between, for that question, how would you know the difference?
If the circle was inscribed in the quadrilateral, it would be inside the quadrilateral.
Okay.
Yeah. So it would be touching all points of the quadrilateral. Good. Number 6, which angles appear to be to intercept major arcs? Hannah?
Angle A.
Angle A?
Yeah.
Okay. Think that's a major arc, so you think DB is a major arc?
Wait. Angle C.
Angle C? So you think AB is a major arc. DAB is a major arc, excuse me.
Okay, never mind.
Well, you had a right answer there. I was just making sure you're confident.
I give up.
Don't give up. We don't give up. Unbelievable. You're wearing a Disney shirt, too. Yes?
B. Oh, wait. Which is a major? Okay. Is it the angle? Yeah, B.
So you think angle B is a major, or intercepts a major arc. So you think it intercepts A. So you're saying ADC is a major arc.
Yeah. Yeah.
How many agree with that? ADC is a major arc. That is true. Angle B intercepts a major arc. Okay? Oh, let's go another group. I can't take all this group. I know that's not fair. Okay, Nick, the train came back. Oh.
What's the difference between a major and a minor?
Major arc is great. Well, what is a major arc? Andrew, what's a major arc?
Isn't the arc when the arc's greater than 180?
Good, 180 or greater. Okay. Hannah, did you have Did you have one?
I was just going to answer that.
Oh, okay. All right, Jody, what do you got?
Angle C.
Angle C. That's what Hannah said. So what you're saying is DAB is a major arc?
Yeah.
That is true. Good job. All right. Any others? Trevor, flexing it up. What do you think? Huh? Nick? Angle D? So you're saying CBA is a major arc. Is that true?
Yeah. No.
So, so here's how I test it, because it almost looks like it, right? So it has to be greater than 180. So there's my straight line, and it hits C. Does it hit A? No, so it's not quite, but it looks like it. Now when you take this away, it looks like it, but when you put that in, it's tougher. So we could actually test B like that as well, right? So B, we're saying it has to go to A, D, C. So there's A, and there's C, and our straight line for going through the center would be right here. It would hit here. So when we go further, yep, that's a major. And same thing with this one here. Everyone see that? Okay, so these are our two angles. What type of angles are they? Andrew? They are obtuse. Good. Obtuse angles will give you arcs that are greater than 180. Okay? Obtuse means that it's greater than, the angle is greater than what?
90.
Angle is greater than or equal, well, they're greater than 90. Okay? Key piece there. All right. You ready? That's so blurry. Ready to move on?
Yeah.
That's still blurry, but we're moving on. All right. We talked, and that's already done. Okay. Let's talk about some theorems. These are amazing theorems. Hopefully you drew some amazing pictures for your amazing theorems. The measure of an inscribed angle is half the measure of the intercepted arc. So right here, if we have this inscribed angle, angle B, here's our intercepted arc, AC. So this angle is half of that arc. So if this arc was, say, 60 degrees, this angle would be 30. That's all it's saying. That's once again, really blurry, but I can't fix it. Hey, I guess I can fix that.
We forgive you.
Okay? Any questions on that? Now the mathese here gets a little difficult, and they talk about 3 different cases, and you may be fine with the cases. The intercepted arc, all 3 points, if you think of it that way, would have to lie on the circle. That's going to be a big deal because we're going to move on to another section next week, and you're going to see angles inside your circle, but those angles aren't going to be touching the outer edge every time. So for instance, you may see a picture like this next week where you have that. This angle right here is not an inscribed angle. It's not hitting all parts. So it doesn't have the same properties that this does. Okay, so kind of a difference. Huh?
That's not for the quality.
So case 1, the center is on the side of an angle. Here, we split the center, and here, our angle is on one side of the center. So in all 3 cases, though, your angle hits. Okay? Note the difference between those pictures and this type of picture. Here, my angle doesn't, only 2 parts of it touch. Or 2 parts of it this way, or 2 parts of it this way, or so on. Everyone clear on that? Okay, good. Corollary, let's talk about our corollary. Hey, Trevor, what you got? You just waving your hand? Oh, what were you doing? Oh. I sometimes do that too. Okay. Two inscribed angles that intercept the same arc are congruent. How many drew a picture of that?
I'm still on those. Yeah.
How many are on these right now? I want a good picture for number one.
Okay.
Draw a picture on your paper right now. Show your neighbor after you draw here.
Yeah.
All right. So we've got Eli's picture.
That's a pretty picture.
Yep, pretty. Okay, so I'm guessing this angle and this angle, right? And they intercept this arc. Therefore, those two angles are congruent. Right? Yeah, very good. Yeah. How many have a picture like that? Good. Okay, we also have Lily's picture. Similar type deal where this angle and this angle intercept that arc and shown they're congruent. Good job. All right, let's see a picture for Corollary 2. Yeah, my picture that I didn't finish, but I like my circle. All right. I got interrupted by my group member up here. Okay. An angle inscribed in a semicircle is a right angle. Draw the picture. Alex, sorry. I'm sorry.
It's not very pretty.
Where is it? Okay. All right. Okay. Here is Allie's.
It's beautiful.
Okay. An angle inscribed in a semicircle is a right angle. Right? That is a semicircle. Can I use my cool pen?
No.
It doesn't erase unless you use whiteout. Okay? That's our semicircle. And here's our right angle. It's half a circle, right? So this right angle gives us, or this semicircle gives us a right angle. Remember, semicircle is 180 degrees, and this angle is half of that arc. So that makes that 90. So if you see that your angle intersects at intersects a semicircle, you automatically know it's a right angle. That's kind of cool because we like right triangles that you sometimes can draw in there, as I kind of did there. Okay. Thank you. Well done. Okay, Corollary 3. The opposite angles of a quadrilateral inscribed in a circle are supplementary. Okay? Did you guys do that one? Draw a picture. Catherine, can I borrow yours? Yeah. Opposite angles of a quadrilateral in a circle are supplementary. So a picture showing that. Do I get to draw all over? Can I make faces on it? Cool. All right. Corollary 3. All right. There we've got it. Okay, they're supplementary, and you'll notice in this one it cuts in. She's actually used her lines to her advantage there. Nice job. Okay, she's got the diameter here. Got right angles on each side, and so these are both 90. In fact, these are going to be both 90. Are they always 90?
No.
Does anyone have an example of one that's not 90?
Got you.
Okay, Jordan, bring yours up. Catherine, here's yours.
One's 170.
I'll meet you guys both ways.
Which one's 170?
Okay. Bottom corner there. Okay. So here's one in Catherine, or excuse me, in Jordan's, that if I take my cool guy thing there, it almost looks like right angles on that one. Okay. You draw your straight line. Okay. Good. Those are close. They look really close. Does anyone have like an example where it's like way not?
Oh, not way not.
Jordan, thank you.
I'm so way not. Yours is so
Jordan, you have good notes.
Really?
Yeah.
I do too.
Sheesh.
Mine have
all right. Hey, there's one right there. I'll bring yours back to you here in a minute, Jordan. Okay, so on this one, notice if our center of the circle, let's say, is about right there. This angle, well, this is definitely an obtuse angle. And this angle may not be, it looks like it's a little acute. It has to be if these two make 180 degrees. Opposites have to make what?
180.
180, okay? Because it makes that takes up the whole circle. Right? So if I go, this angle takes up this much. This angle takes up this much. Notice I've taken up all 360 degrees, and half of 360 is 180. Okay. Hey, we are now to where want to be done. Any questions with that?
Are we doing theorem 211?
I want to talk about this theorem real quick. 1211. No, it's the same type of theorem. Okay? Has everyone went through theorem 1211? No. Okay, copy that theorem down. So note this theorem is really similar to the other one. In this one you have angle C is half of arc BD, or BDC in this case. Okay? So angle C, this angle, is half of the measure of that arc. Or this angle is half of the measure of the intercepted arc. So this is where a tangent line hits a chord. Okay? The angle formed by the tangent and the chord intersecting is half of the measure of the intercepted arc from that chord to that, where that chord hits. Okay? And the reason is, it's the same type of theorem, so we lump them in together. If you look at this picture, this is in the book, but you'll notice we went through and we said, hey, angle A is half of the intercepted arc BC. So if you like put a nail at B and a nail at C and make those anchored down, and you just start grabbing A and sliding it around the circle, which is what we're doing here. As you keep doing that, the angle is still half that arc, still the same. Once we get to where A and C are the exact same point, you still have that same angle, and you still have that same arc. Okay, so really what you're doing is you're applying the previous theorem in a different way. Everyone see that? So there are two different theorems that you want to have an example of both of those on your note card, but they're very similar in the way that we use them. Okay? Right? Raising your knee now, Trevor. Good job. Okay? Got the knee up. I can't bring my knee up like that anymore, though. My knee hurt. Just saying. Okay, I want everyone to take a look at number 1. Example 1, number 1 on your assignment. Talk with your neighbors. You guys get about 1 minute. All right, what do we got? What's angle X? Hannah?
100.
100. How many got 100? Why is it 100? Alyssa, why is it 100?
Because the angle, like the inscribed angle part, is half of the arc angle.
Good. Yeah, so that's half of it. So if we double that, we get 100. Okay, so what's y going to be then? Andrew?
20.
20, yeah, it's half of 40. Okay, y equals 20 degrees. Okay, we're good. How about number 2? Number 2. Hannah, what do you think?
Y equals 140 degrees.
Y equals 140. So there's our intercepted arc. So for those of you still having a hard time seeing that, just trace the arc. That's set, or trace the angle. That's 70. The intercepted arc then is 140. Okay? And what do we know about angle X, this angle, and this angle? JJ? They're congruent. This has to be 70. JJ, why are they congruent?
Because they intercept the same arc.
Good. They intercept the same arc. Okay. Any questions there? Tried to set you up on that question. A little foreshadowing there. Okay. For number 7, everyone take a look at number 7. Go ahead and work with your group. You can talk about it. Okay, give me a pair of congruent inscribed angles here. Hannah, what do you think?
Me?
Yep.
Well, I gotta make sure. Gotcha. EA or angle EAD is congruent to angle DBE.
EAD. So you're going here.
Thanks for the support.
And DBE.
Yep.
Okay. Eli, did you get that one? Yeah?
Well, I put angle E, angle D.
Can we say angle E and angle D? Can't do that. You have to name them by 3 points. Jordan?
Also AEB and ABB.
A what?
AEB and ABB.
A B. Oh, AEB. AEB. Yep. Yep. You can do it that way. Any others that work? No others? All right. How about number 10? Everyone take a look at 10. Example 3, number 10. Find the values x, y, and z. Give it a go. Let's check y. What's y? 90. How do I know it's 90? Raise your hand, please. Jody.
Because it's it's angles and at the sun is.
Good. It's intercepted arc you have a semicircle for. Okay, so 180, so this is 90. Okay, what's x then?
60.
How do you know that, Nick?
Because it's a 30, 60, 90 triangle.
30, 60, 90 triangle. Okay, so there are a couple of ways to figure out z. Z is half of this arc. Remember, that was that last theorem. So if I can figure that arc out, I can figure z out. And there's two ways, well, a couple ways to figure out that. Yeah. The easiest way isn't the way I just showed Nick. Sorry, Nick. Okay, is right here. This is 60 degrees, this angle, which makes this arc 120, which makes this 60. The other way, you could say this is 30, which makes this arc over here 60, and this whole arc is 180, so that makes that 120. Oh, you guys could tell me to zoom in. Yeah. Better late than never, I guess.
Yeah.
Okay. All right. Everyone rate themselves 1 to 5. 5, you got it. 1, you don't got it. No half fingers. Only appropriate ones. Very good. Okay. Thank you. Your assignment is the example side right now and number 13 and 14 on the back. Example plus 13 and 14.
What did you get from
Number 9. Okay, on number 9, make sure you're paying attention now, so get to a stopping point wherever you're at. Okay, so this angle right here is congruent to that. How do we know that? Vertical angles. Meaning, yesterday or one of the days this week, we talked about central angles. We talked about it earlier this year. Are equal to their arcs. Yes. Right? So this arc, BC, is congruent to arc AD. Which means any angle that intersects those arcs, so like for instance this angle, ABD, would be congruent to any angle intercepting this other arc. Or, in this case, CAB.
Crazy, we were close.
Okay. Does that make more sense now?
Yeah.
Okay. All right. I want you to take out yesterday's